functions with, or modeling with functions.
Actually, it depends on how you play.
Just to be clear, y'all didn't have any notes on this section, right? Okay. Just wanted to make sure before I start doing what I'm about to do, y'all aren't just going to be like, yeah, I already have this. All right, functions from formulas. So, for example, write the area of a circle as a function of, and we're going to do it as in 3 different ways. So the first one of radius r. So this one is just the generic area of a circle, and what is that formula?
Radius of a circle?
Area of a circle.
Oh, it's r squared times pi.
Pi r squared. So obviously that's just the generic, we already know that one. B, instead they want us to write it as a function of diameter d. So instead of r, we're going to be using d. So what is the relationship of d to r?
D over 2 squared times pi.
So a equals pi times d over 2 squared, which we would write as pi over 4 times d squared. Then they want us to do it as a function of circumference c. So, what is the formula for circumference of a circle?
Is it?
Isn't 360?
Just your basic circumference of a circle.
Is it something to do with anything we've just covered, like the radius or diameter? Like, can the diameter give us the circumference?
Where I just want the equation for circumference. We should know this.
Pi times r.
Huh?
Pi times radius.
That's part of it.
Oh.
Pi, 2 pi times radius.
2 pi r is the equation for circumference. Now, in area, the only thing that is the same, okay, in terms of a variable is r. So I need to solve for r. I need to get r by itself in the circumference formula. So with r by itself, what am I left with?
Equals negative 2 pi? Oh, wait, no. Equals 2 pi over r.
In this equation, I need r by itself.
C over 2 pi.
C over 2 pi. So now I have radius, okay, written as a function of circumference, but I need area written as a function of circumference. So I'm going to have A equals pi times C over 2 pi squared, which is pi, well, not 4, I don't know why I wrote 4, pi times C squared over 4 pi squared. The pi's will reduce, and so I end up with C squared over 4 pi. And that would be the area as a function of circumference. So a bunch of different ways to write the same area formula, depending on what we would be given and what we need. The next thing we're going to do is look at a max value problem. A square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard. And the sides are folded up to form an open top box. So before we get into what this problem actually wants us to do, I want us to draw a picture of this. So I'm going to have my piece of cardboard here that is 8 inches by 15 inches. They've said I'm cutting a square of side x inches out of each corner. So that means I am cutting a piece out of each one here like this. And the sides of the square are x. So then these are going to be folded along these dotted lines here. To create a box. No, it's not the greatest looking box, but anyways. An open top box, okay? So I'm gonna try to like color it in a little bit here or something. So it's open. Now, what do we know about this side length here? Like about the part that's left over.
It's 8 inches. Oh wait, no, what side line?
The part that's left over when I've cut out the stuff.
Oh, it's minus x squared.
It's 8 minus 2x.
8 minus 2x. Because I've taken out x on each side of that edge. And then 8 was the total. What about on this, the longer side? Yep, 15 minus 2x. So now I'm going to use all that information to answer the questions that they're about to ask me. Part A, write the volume of a box as a function of x.
So length times the width times height.
Yep. So volume of a box is length times width times height. So my length is 15 minus 2x. My width is 8 minus 2x. What's the height of the box?
X.
X, yep, because that's the part that gets cut out. So this is my equation. I would not multiply it through. I would just leave it like that. Because that's a perfectly legit function for the volume of a box. Part B says to find the max volume. Okay, because depending on what the amount is that I cut out exactly will depend on the volume of the box, right? Like it's not going to stay the same regardless. So what we're going to do is we are going to type this function into our y equals. So type it in just as it's there.
Max volume. Would it be 88?
We're not done yet. Just all I've said is type this in. All right, does everybody have it typed in?
Yes.
All right, hit zoom, 6 for standard. Now, I can't see the whole graph, so I'm probably going to have to zoom out so I can see it. So zoom 3 is zoom out. Maybe. I still can't see it. Okay. Hit window at the top. Make your X-Men -10. Make your X-Max 40. Scale of 2. Make your Y-Min -10. Y max, let's go up to like 100. This may still not be enough, but I'm just trying and seeing what happens. And I would do a scale of like probably 5 on this one since it's so wide. Then hit graph. Do not hit zoom again or you'll have to start all over. Just hit the graph button.
We see the first thing.
Huh?
Are we supposed to see the second thing that goes up or not?
I mean, you're not going to see all of that. So this graph, what's happening, it's kind of hard to see just because of how tight it is here, but it's going up and then it's looping back down. Okay, do we see that? Okay, so where it goes up and turns around, that's going to be our max value. Your calculator, fortunately enough, calculates that for you. You've got to hit second and then trace. It's up here at the top. And you'll see all these different calculate options. Maximum is option 4. You're going to click that. Is everybody with me so far? Before I click that. Okay. Hit that. Then what you're going to do is it says it's going to ask you for left bound. So I'm going to arrow to the left until I can find my little thingy. There it is. So notice it's up here. It's flashing. I want it arrowed over to where it's on the left side of this hump. Okay. I don't care where on the left side. It just needs to be somewhere over here. So I'm going to do that. Hit enter. It put a little dart looking thing right here. It's hard to see. Then over on the other side, it says right bound. So arrow to the right. Notice I'm over here on the right hand side. It's flashing now. Once it's over there, hit enter again. Then it says, do you want me to guess? Okay, obviously if I ask you the question, I want you to guess. So hit enter. And now it comes up and it tells you the max value occurs at 1.666 and so on. And y equals 90.7. So the max volume is the y value, which is going to be 90.74, and it's in inches, and volume is cubed. Part C says, what side length
Basically.
should, yes,
So graphic, do I need my, sometimes on my stack plots, do I always have it like on or off?
they need to be off.
Okay.
What side length should the squares have that are cut out? So the side length that needs to be cut out is this x value. So we'll just round that to 2 decimal places also. So 1.67 inches is the side length that's being cut out to give us the max volume for our box. So y value is the volume, x value is what's being cut out. Did everybody follow? Nobody got stuck anywhere? Okay, perfect. All right, now actually getting into some of the problems. We probably won't get through all of them today because there are a decent amount, so we'll probably wrap them up tomorrow. Number 2. These ones say, for exercise 1 through 10, write a mathematical expression for the quantity described verbally. So 2, a number x increased by 5 and then tripled. Any ideas on how I would write an equation for that?
X or 5x. No, x times 5.
Increased by 5.
Oh, x
So
plus
x
5.
plus 5.
X plus 5, then tripled. Tripled
Times 3.
times 3. It would say cubed if it wanted you to raise it to a power. So tripled just means take it and multiply it by that number. So 3 times x plus 5 would be that equation. Four says 4 more than 5% of a number x.
So 5 over x plus 4? Or no?
5% of a number x.
Oh, 5 over 100 times x
4
plus
plus
4?
4 plus x over 20.
Can we not just
How do I write a percent?
Wait,
5 over 100?
4.05.
0.05.
Oh, that's more.
So 0.05 times x. So that's 5% of the number x. And 4 more than that plus 4. And 4 can go in front or the back. It doesn't matter.
But would we get it right if we said 5 over 100?
No, because that could be reduced.
But we're gonna do
And it's a percent. You should write it as a decimal, not a fraction. 6 is an area of a triangle. The area
It's the same.
of a triangle
You said, I said 4 plus
whose altitude is 2 more than the base length x. Tristan, to answer your question, that would not be right because it told us to use the stuff that's given.
Oh, okay.
Yes, it will give you the same answer, but it needs to be run like this.
Okay, so
What is the equation
altitude
for
is height?
what is the equation for area of a triangle?
Whatever base times height.
Area of a triangle is 1/2 base times height. So, what is altitude?
Height.
Altitude is height. So the area of a triangle whose altitude is 2 more than the base length x. So I need to rewrite this stuff in terms of x and 2 more than x. So how would I write this one?
1/2 times x plus 2.
Yep. And you just leave it like that. Eight. Income after a 3% drop in the current income of X dollars. So basically this one's saying what would the income be if there has been a 3% drop?
Point times 0.97x.
Yep. Because the amount that we actually have is 0.97. There was a 3% drop, so you have to do 1 minus 0.03. Okay, the next one say to write the specified quantity as a function of the specified variable. It will help in each case to draw a picture. So number 16 says 1 leg of a right triangle is twice as long as the other. Write the length of the hypotenuse as a function of the length of the shorter leg. So the legs are the other 2 side lengths. That's not the hypotenuse. So we want to write the length of the hypotenuse as a function of the length of the shorter leg. So I'm dealing with a right triangle.
They just meant as a function of x, no? Because the shorter leg is x.
There's nothing that says that it's x.
Well, we could put it as x if we know that the other one's 2x.
I'm not going to use x. So, write the length of the hypotenuse as a function of the length of the shorter leg. So, I know that one leg is twice as long as the other. I'm going to call them H. And the hypotenuse, we'll call it C. That's what we normally refer to the hypotenuse as. So, I need to basically come up with an equation for solving for the hypotenuse, or writing the hypotenuse in terms of the lengths of the other leg. So, what equation do I normally do when I'm using a right triangle? Pythagorean theorem, which is a squared plus b squared equals c squared. So c is the square root of a squared plus b squared. It doesn't matter which one I call a and which one I call b, so I'm just going to put them in an order. C is equal to the square root of h squared plus 2h squared. Which gives me the square root of h squared plus 4h squared, so that's 5h squared. Something in there is being squared, so I can take it out. So c equals h times the square root of 5. So that would be the hypotenuse as a function of the shorter leg. (18) A square is inscribed in a circle write the area of the square as a function of the radius of the circle.
I think I saw one of these on the SAT practice test.
It's very possible. All right, so I have a circle, and there is a square inscribed in it. The radius would be here. It would also be here. It would go all the way around, but I'm not going to write it multiple times. So a couple things that I know is that the radius is half the diagonal of a square. S is the side length of a square. So I've got the radius here, S here. What do I know about this triangle?
sides of either, right?
Yeah, the two things that make up the radius of.
So this is also a radius. What else do I know?
Oh, that is a 45, 45
It
triangle.
makes an arc.
This has to be a right triangle. Okay.
And then the others have to be 45, right?
Yes, it would have to be a 45, 45, 90 triangle because all of these angles would be 90, so half of them would be 45.
And
So this is a right triangle. I can use the Pythagorean theorem.
And with these kind of triangles, is it like to get to the hypotenuse, you have to like multiply it by square root of like 2 or something?
I'm using the Pythagorean theorem. So s squared is equal to r squared plus r squared. Or I can say that s is equal to the square root of 2r squared. Or s is equal to r times the square root of 2. Now they want the area of the square as a function of the radius. So basically I've now taken and I've made one side length be written as a function of the radius. What in general is my area of a square? Yep, side times side or side squared. So now I take this value for side and I plug it in. So this is equal to r times the square root of 2 squared. What do I get when I do that?
R squared.
2r squared. So my area of this square as a function of radius would be 2r squared. All right, one more. So we might actually finish it. 27. And obviously I don't normally do an odd one, but I want us to see this one. 27 is at a shirt sale. Jackson sees 2 shirts. That he likes equally well. Which is a better bargain and why? I'm just going to do it this way. I'm not going to draw the pictures of the shirt. But shirt 1 is $33 and it is 40% off. Shirt 2 is $27 and it is 25% off. So basically, I want to see at the end of the day which shirt is cheaper. So to do this, we take the price of the shirt. So the first one is $33. And we multiply it by basically 100 minus this, okay, or 1 minus the decimal. And that's going to tell us what we actually will pay. If you multiply it by the percent off, that tells you how much you get off. Then you have to go to another whole level of subtraction. So if you multiply it by like this first one, 0.6 instead of 0.4, it'll tell you the price you pay, and it's less math that you have to do. So 33 times 0.6. Somebody want to type that in and tell me what it is? So, and it's money, so we want 2 decimal places, $19.80. Then the other shirt, we would do 27 times 0.75, so we get what we actually are paying. 27 times 0.75 gives me $20.25. So which shirt is the better bargain? Shirt one.
What was like the rule or like the way to like skip out on the subtraction?
To do what I just did.
How?
So like it's
So the way that you've probably been taught to do it before, because this is the way most people teach it, is that you have like a $33 shirt, you multiply it by 0.4, and that's going to give you $13.20. Then what you have to do is you have to go $33 minus $13.20, so that would then give you $19.80. So I saved you a step by saying multiply by 0.6 instead of by 0.4.
Well, how did you get to 0.6?
Well, you say one.
The total amount up to 100%.
Four.
So
Okay.
I get 40% off, so I'm paying 60% of the price. So this is what I do when I go shopping and they're like something is X percentage off. I always multiply by what I'm actually going to be paying. So like if something is 40% off, I multiply it by 0.6 so that I know exactly what I'm paying. I'm not sitting there trying to calculate, well, I get this much money off, so then I have to do this. Like, it's just easier, and a lot of people don't know that trick, so hoping this will make your life easier.
When you go to the store, you actually do the math. You get on a calculator.
A lot of times I can do it in my head. I mean, it's not that hard.
So that's the one thing that actually applies to real life, you know?
I mean, I like to know exactly what I'm paying when I go to the store, if I'm getting a discount, see if it's worth it or not. So, all right, problems, and you will have tomorrow to do them because there's not that much time left. And there's probably one more we're going to look at tomorrow as well, just because you need to understand how it works. 1, 3, 5, 9, 15, 21, 23, and 25. 39, go ahead and write that one down, but we're going to do that one together tomorrow at some point. Maybe not at the beginning. I don't know yet. But that one has like some major conversions that you need to make sure you know how to do. So that's why I'm going to put that one on there. Anyways. And this is the last section. So Quiz Friday, which I think is what's already up there. But just to make sure.